Okay.
Okay, so welcome everyone and Happy New Year. So this is the first webinar for 2025, and that happens to be the webinar number 32 for the Reclaim Network Plus. So just to introduce the network very briefly to who haven't really attended the previous one. So this is the network which is run by the University of Surrey in collaboration with the UKCEH, Bangor, Warwick, and University of Bath. This is the list of our the collaborators, the co-investigators, the co-leads, basically. So we got today Professor Laurence Jones, so he will be taking care of the question and answer session. I will talk about that. And then there are colleagues from the other universities bringing in very adverse kind of, the diverse expertise. We also got our network managers, Mark Simmons and Charlotte Glazier, who have been really driving basically the network activities. So these webinars, they usually run every Wednesday of every month. The first Wednesday of every month, that's starting from 12:30 to 13:30. Usually have two speakers, try to have a mix actually. So having them coming from the academic and non-academic backgrounds. And all these webinars are recorded. So you can go onto our YouTube channel and you should be able to, to kind of see the previous recording there. So the network has grown quite substantially. We have around 650 members over the last 2 years, 2.5 years, in fact, and we got the extension, so the network will be running until August 2025. So they come from a variety of, the backgrounds, having public health and well-being, trees, and you can see the big list, and having quite a lot of interest in the different type of ecosystem services this green and blue infrastructure provides. So as a Reclaim network, we have been doing quite a lot of activities in terms of funding the project, secondments, workshops. So in fact, there are 2 calls which are currently open on the workshop and secondment. So if you are here and if you want to apply for them, so that could be an opportunity there. And there is there are some ongoing activities in the GPJ database and the CPD courses which we are developing. And so there is quite a lot going on. So if you go onto the Reclaim Network website, so you can find that information. And if you're on LinkedIn, on X, you could also follow the activities. So before I introduce our next speaker, so just to invite you to our Reclaim Network conference, which is happening on 30th of January at the university campus. So we welcome you all. So the registrations are free and open. So please go onto the Reclaim website and you can find the link. We can paste that into the chat box as well to have a look on there. So just to say that some of these webinars, actually we have been collaborating with the different projects going on in this particular area. So one of the projects is funded by the UGPN NBS project, which is called Prescription of Nature-Based Solutions to Cities. So that's between the state of North Carolina State University, University of Sao Paulo, University of Surrey. And the whole idea there is to develop this, the multinational, multidisciplinary network that is looking into the different methods and approaches to enhance the implementation of the nature-based solutions from the perspective of mitigating against the environmental and the climate challenges the cities are facing. So today, we got 2 fantastic speakers. So our first speaker is Charlotte Glazier. She's the founder of the UK Pocket Parks, and she'll be talking about the Green Explorers. And the second speaker we have is Dr. Daniel Green. He's an assistant professor at Heriot-Watt University, and he will be talking about the data collection related to the nature-based solutions. So before further ado, I'm going to invite to our first speaker, Charlotte Glazier. She's a change agent and a program manager and chartered landscape architect with local authority background. After local climate emergency declarations in 2019, she went on pioneering 2 of the most innovative urban greening climate adaptation programs, namely Islington Greener Together and Green Finance for Islington Pocket Park Framework, NEIRF, which researched alternative finance and new steward models. Her ambition to scale up urban climate adaptation continues. On her own terms, she pledged to ignite a UK child-led urban greening movement on 7th October 2024 on United Nations World Habitat Day, and pilots are now live. So we are really grateful for Charlotte for her time and giving us our audience the opportunity to speak about her work. But before I hand it over to her, just to say a couple of housekeeping things. So these webinars are recorded, so they will go onto the Reclaim Network Plus YouTube channel, so you can get access to them later on. Please keep if you have any questions, can you please write those questions, and in Q&A chat box is there, and you can write your name and also the affiliation if you want that to be spoken with your question there. We are going to take all these questions towards the end of both presentations. So each of the speakers have 20 minutes, and Professor Laurence Jones will be chairing that Q&A session. So with that, I will hand over to Charlotte.
Thank you so much, Prashant. It's great to be here, and I'm really looking forward to sharing the journey so far of Look Out, Child-Led Urban Greening Ahead. So next slide, please, Charlotte. So a little bit about myself, which you've already heard, but yes, I have a background as a landscape architect, and I've mainly been in the realm of delivering public realm programs for the last 20-30 years, specializing in community engagement with an empowerment in these projects, and also really sort of tackling the complexities of inner city urban situations. So I'm also a mother, which is relevant because this is child-led, and it really does give a different perspective for the needs in our urban settings. And I also live in an urban area of green deficit. So again, it's sort of compounding the reality that climate adaptation in the cities is a real issue. So I'm just keen to share this with you. This is from a sort of non-academic passion purpose-led program. So to the next slide, please, Charlotte. So having been a landscape architect in local authority and a project and program manager, it has been difficult because the opportunity has been there to urban green and deliver green infrastructure and blue infrastructure, but the funding hasn't been there, and particularly around the revenue. So it's another aspect of having everyday highways projects is that the engineer has predominantly designed the layout, and then they create these little green blobs for the landscape architects to fill in, which hasn't been really fulfilling for, I think, anybody. And so I think the role of landscape architecture in-house for local authorities hasn't always been an easy sort of relationship, and actually to the point that a lot of the skill base was actually being made redundant in various councils across the UK. So to the next slide, please. So one of the things about highways is obviously the fact that there has been a lot of potential to deliver the uplift in urban greening and nature-based solutions and ecosystem services, but there hasn't been the revenue. Next slide, please. Going the other way. Thank you. So in 2019, about 70% of local authorities declared the climate emergency, and this, for the first time, really unlocked the potential and broadened the bandwidth of what was possible in the public realm. And for the first time in my career, it felt like I was pushing an open door, to the point that I was really part of a first wave of quite significant climate adaptation initiatives, and I was able to pioneer some of those. So the next slide, please. Yes, so basically changing the outlook of the highway for just traffic dominated to actually the multiple benefits, and now really seeing nature and urban greening as an essential rather than a desirable and something that could just be chopped out of budget. It's now incoming and it's here to stay. Next slide, please. So all the benefits of urban greening, probably everybody on this call is very much aware of, but they extend to the social, the health and well-being and educational benefits, as well as the environmental and the increasing of biodiversity in abundance and frequency, as well as climate adaptation, reducing heat island effect, air pollution and flood risk. And the economic benefits obviously extend to kind of increased footfall and help, there's a lot of benefits, but I'm not going to go into all of these because that's not my presentation right now. And the opportunities to really empower communities in that has not been lost. So to the next slide, please. So whilst I was at Islington, I pioneered the NEIRF program, which is the Natural Environment Investment Readiness Fund. And what I had done is identified an opportunity to look at the multiple benefits of the pocket parks and look at how they could be scaled up in the borough. So in that instance, I found approximately 1,000 possible locations just in that borough. And, with those pocket parks costing about 150k each, the kind of scale of ambition just for one borough alone was looking at 50 million. So then seeing the potential for just those sort of indicative statistics, that really does look at an opportunity of, well, if this is what the opportunity is on just that basis alone, who's actually going to fund this? And so actually put a bid together with WSP, and we started to look at how we can actually drive different types of routes of investment into the delivery of urban greening and green and blue infrastructure, nature-based solutions. So at that point, it really was about, looking at repurposing the streets and getting those multiple benefits, but more so about switching the dial from what was the traditional routes to financing, such as the Section 106, the SIL, looking at the bids, but actually looking at new different types of funding routes, such as ESG, and again, other sort of new financial drivers coming in around the sort of TNFD and green taxonomy. So but a lot of this is also on a longer term trajectory. And even with all the research in terms of looking at the return on investment, the case was actually still really challenging. And although we can look ahead and say, well, these drivers are going to change and return on investment will increase over time as the new policy drivers come into play, that's not the case. Yet we need the interventions now. So next slide, please. So what I took away from that research piece was that the environmental ecosystem services, in terms of scaling up on the urban setting, they weren't at the scale that we could actually get the investment in. And so that the area that was probably less tapped into was the social aspects, actually having social as the key driver to deliver the environmental benefits in green and blue infrastructure. So to the next slide, please. So therefore, my sort of main emphasis has now shifted into the sort of social value and impact areas, and looking at corporate companies around the sort of ESG and the corporate social responsibility to really help fuel these new sort of community-led urban greening initiatives, because it's this juxtaposition or this sort of combination of factors which will take away the revenue problem that's been associated with highways by empowering communities and giving a new revenue source into enabling the legacy impact of urban greening, which to date we haven't really had, or we've only had in sort of ad hoc way. So my sort of overall aim is to look at creating a sort of new social franchise that can be replicated elsewhere. And I'm currently looking at testing out some of these sort of newfangled theories that I've got going on. So next slide, please. So I'm a mother, and living in an urban environment. To my horror, my 6-year-old said to me, "It's dark outside," and I was just like, "What on earth is going on?" But I realised that actually most of our view from the window is buildings, and she's not really going outside in the evening because we live in the flats. We've got 4 sets of stairs. And when she said it was dark outside, it was because we were somewhere that the front door just opened out into the outdoors. It was a summer evening. And that sort of disconnect from nature is really pronounced. We also have this sort of, theory that there's a lot about, children, the sort of future caretakers of our planet. And, they've got this sort of stewardship role, and they're going to embrace all this lovely green stuff, and they're going to do the job that we didn't quite do. But next slide, please. But the reality is that, that our children are kind of dislocated, and the urban public realm is quite a hostile place. I mean, even just looking at my childhood and speaking to other parents about when we were out being independent and the age of independence now, looking at a difference of about 5 or 6 years. And that difference of children being inside, disconnected from nature, is something that we collectively as community now are looking to start to overcome, and start to look at how we can reclaim the public realm for our younger children, and so that they are comfortable to play in it and to engage with nature, etc. So to the next slide, please. But also that this problem is not a new problem. This is Elizabeth Rossetier, and she is a local social reformer in Southwark. And 150 years ago, she was still talking about children at the top of stairwells, not able to having access to nature. And, here we are 150 years on, still fighting the same similar battles. Next slide, please. So I thought, right, what can I do about this? What can I personally do about this? I'm not Aviva Insurance. I can't say to them, it's a really good idea that you invest in, green infrastructure. I haven't got that ability. So what can I do as a mother who's passionate about, public realm and climate adaptation? Well, on the 7th of October, I made a pledge to kind of ignite a sort of child-led urban greening movement. And every journey starts with a first step. So I thought, why not? I'm just going to put my hat in the ring, and I am literally just going to just go there and see what we can do as a community. So next slide, please. So this was the beginning of Green Explorers, which is a child-led urban greening movement. Thank you. Next slide. So the approach that we've got to date is a 4-pronged process. And the first one is connecting with nature. So we've currently been trialing after school pilots, and looking at intuitive walking. So the children actually deciding where they're walking to. And this is really interesting because usually it's like, come along this way, stop messing about, we're going to school type experience for the child. But actually, where you're actually walking in the public realm and say, well, where do you want to go? You bring us along with you. It's because they're supported walks with parents. It was just incredible that something so simple could make such a difference, and you could really just see how empowered children were just to be able to walk around the public realm, because at the sort of primary school age, it's not so prevalent in the inner city London areas. And the second one is canvassing. So actually saying, well, once you've enabled children to actually go and explore the public realm, it's like, well, what would we do here? What if we added something here? What's the opportunity? And the third sort of stage is in the creation, to say, okay, well, now we've found some particular sites, what would we put in it? And actually start to co-design these spaces with the children. And then lastly, the idea of care, and care being incredibly important, as this is where the stewardship model comes in, which is the kind of the link that's going to help drive the revenue into the program. So the next slide, please. So the winter pilot that we did with the Connect on the intuitive walks, we did a GoFundMe, and we raised funds so we could get flasks for hot chocolate and just sort of warm kits, really, so that we could get out and about and experience that. And we've had some great support from our local primary school, Charles Dickens, who are looking to support our official launch for the after school club, which is due to start in spring, as well as amazing collaborations with Luke Power and ECF, who have been working on engagement material with our children at the school. And that's where we've got to on the Connect. Next slide, please. In relation to the canvassing, we've also, from the initial pilots, been walking around and actually starting to ask the what if, and we've started to identify a number of sites. We've also got collaborations with ECF and the London Festival of Architecture. We're due to showcase the children's ideas in June 2025. Next slide, please. And then create aspects. We've got a Southwark Biodiversity Fund bid in with the Downside Fisher Youth Club in looking at converting some of these sites into sort of micro gardens or a sequence of spaces that children can design and then potentially care for. To the next slide, please. And then again, the sort of caring aspect in this child stewardship model. So the looking at the year sort of autumn, spring, summer terms, and how we can provide opportunities for children in those times to actually have care of these spaces, as well as looking at a model of corporate volunteers when it's out of term time. So to the next slide, please. So all in all, this is a kind of 4-cogged model, which some children might lean in more to some of the cogs than other cogs, but together it creates a sort of movement where engaging with children, bringing them in to experience this, and then looking at how we can engage with the corporate social responsibility opportunities, sort of increase the health and well-being, and deliver on the climate adaptation and legacy interventions there. To the next slide, please. So the programme is very much sort of staged over the term times, and like I said, we've got the London Festival of Architecture coming up, and outcomes on biodiversity and delivery. So all going well. We should have some good news soon on various aspects. Good. To the next slide, please. And as mentioned, we've got a great number of local support as well from BOST, which is a local gardening charity, ECF, Blanca Homelova, Chris Brown from Climatize, Downside Fisher Youth Club, a fantastic parent advisory group, and loads of willing parent volunteers, and Charles Dickens Primary School. And the idea is that this is local to Southwark, but the idea of it being actually something that can become a social franchise and scaled up elsewhere. So it's very much a sort of test and learn sort of development type program. And the child-led stewardship model is really key in this, and it's something that we're going to be exploring in a lot more depth. So this is kind of the sort of wireframe of activities, and each sort of cog has quite a lot of involvement, but we're hoping that as a whole sort of systems approach, it will really start to make change for our children, everybody else in the community, and the climate adaptation that we need. To the next slide, please. So yes, so here we are, and if you would like to collaborate, or if you'd like to learn more, or if you'd like to look at research possibilities, or just kind of share the journey, definitely be more than happy to chat through, share, and collaborate. So thank you very much for having me today.
Yeah, thank you very much, Charlotte, for fantastic work and a very nice presentation. I think if you have questions for Charlotte, so please do write them using the Q&A box, and write your name and affiliation, which will be picked up by Prof Laurence Jones after our second speaker has spoken. So before any further ado, I'm gonna introduce to our second speaker of the day. We have Daniel Green. He's an assistant professor in nature-based solutions based at the Heriot-Watt University, and a research associate in nature-based solutions at Royal Botanic Garden, Edinburgh. Prior to working at Heriot-Watt University, Daniel was based at the National Green Infrastructure Facility at Newcastle University, UK, working as a PDRA on the EPSRC Urban Green Dams project, which is design and modeling of SUDs. In this seminar, Daniel will discuss findings from a series of experimental field-based test beds to quantify and assess the performance and functionality of green infrastructure, sustainable design systems, and nature-based systems from a hydrological flood risk management perspective, and outline plans for the new green slope facility testbed at Heriot-Watt University. Very welcome, Daniel, and we're really pleased to have you. So yeah, over to you.
Yeah, brilliant. Thank you so much for the introduction, Prashant, and really interesting presentation from Charlotte. So I'll share my screen now. Hopefully that's gone full screen. Yeah, so I'm going to be talking about, I guess, the other flip side of the coin. But I think this is really interesting, how diverse green infrastructure really is. So my research is predominantly hydrological focused. And today I'll be talking about environmental monitoring and experimental data collection of nature-based solutions. So yeah, I've just put the 4 pillars of SUDS up here. We're all very aware of this. My research is mainly within the sort of water quantity flood risk realm, but because of the Reclaim network, I've been a research associate at the Royal Botanic Garden, Edinburgh. I'm working very closely with the nature-based solutions team there. And this has kind of really opened my eyes up to the importance of biodiversity and also the public amenity value of nature-based solutions. So I think that was really missing in my research before, but now I feel like I'm kind of trying to get up to speed with that. So yeah, a little bit of background and scope. We all know that we should push green infrastructure, nature-based solutions within cities, and that they're really essential to try and ensure that our cities are resilient and also like livable, ready for future change, and we're able to achieve net zero targets. The problem is that monitored data on these systems is really, really lacking. So often there's like a lack of evidence base to try and assess, maximize performance of green infrastructure and really get the most out of our green spaces within the small space that we do have within cities. So yeah, I think really the crux of it is that long-term high-resolution monitored data from fully functional pilot systems is really imperative to try and provide input parameters to aid the hydrological modelling, but also to support decision-making and taking green infrastructure into the mainstream. So Today I'm going to be talking, my first part of my presentation will be looking at bioretention cell or rain garden lysimeters, which within my postdoc at Newcastle University I'd worked on setting up. So this was a collaboration between Newcastle University and the University of Sheffield on an EPSRC research project. So yeah, these pictures just show the lysimeters. So from these lysimeters, we had four large-scale lysimeters, 2 meter by 2 meter with a 1.2 meter deep profile. And these were split into 2 hydrologically isolated cells. Now I'll talk about the differences between those cells in a second, but these were based at the National Green Infrastructure Facility. And this video that's going around now, we see this is the commissioning process of putting the soil and the sensors and the vegetation in, so we can collect data on these systems. Now, these are commissioned to provide pilot scale analyses of bioretention cells operating under both natural and also simulated weather conditions. So the idea was that these were outside systems, they would receive natural rainfall, but we also developed a runoff simulator to try and almost augment or simulate additional inflows of runoff. And the idea was that because these systems were raised above ground by 1.2 meters, they weren't actually receiving any inflow from the surrounding catchment, which is good because we can completely isolate the inflows that are going in terms of, it's only rainfall. But when we really want to push these systems to the max, we want that runoff simulator to simulate water coming in from, for example, a nearby car park or similar. Now, all 4 of these bioretention cells, so there's four lysimeters split into 2, and they're all identical in design specifications, apart from featuring the 4 different vegetation styles that you can see there. So we've got bare earth control, we've got a low sort of amenity grass reference situation, and then we have 2 monocultured bioretention cells. So these were based on typical SUDS planting styles. So we've got the Iris sibirica and Adeschampsia cespitosa. And the idea behind these would we would get 3 different evapotranspiration scenarios between the vegetation planting styles. And then also we've got the 2 cells in each of those 4 lysimeters. So one was a completely unrestricted outflow. So water would just go out of the cell and into the sewer system below. It was a gauged, so we were able to measure the outflow. And then also the other one was a restricted outflow, so we were able to control the orifice size to reduce the amount of water coming out. So rather than relying 100% on the substrate and the vegetation to do all of the hard work about attenuating, slowing the flow, we've got a restriction there, so we're actually able to back up the water within these systems. And this picture here at the bottom just shows a rough sort of sketch of the makeup of the soil profile. So you can see the bulk of it is a SUDS substrate, and then we go into the transition layer and the drainage aggregate at the bottom. Now in there, we put a distributed sensor network to measure any inflows, soil storages and outflows to conduct lysimeter mass balance at a storm event scale, but also on the long term. And yeah, so lysimeter data is automatically uploaded and available via the NGIF online data app there. So this just shows it in a little bit more detail. We can see one side shows the key processes that are happening. The other side shows the sensor network, which was within the soil profile here. And at the bottom, yeah, so we can see the rain gauge at the top to monitor inflows. And we can see at the bottom, we've got the tip and bucket flow gauges to measure any outflows. This just shows some of the vegetation scenarios, and underneath there's the sort of tip and buckets to collect any outflow from the systems. So I won't go into too much detail about this, but we had approximately 130 separate hydrological, climatic and soil specific variables being measured and recorded at each time step per lysimeter. So we're looking at about 5 minute or 15-minute data for a large proportion of these variables. And here I've just put a subset of the data to show some of the inflows, the storages in terms of the volumetric water content from the sensors, and also the outflow rates here as well. The area that I've indicated here in red, we can see there's a bit of a drying, so we don't see much daily rainfall going into the system, and we'd see higher soil water storage and outflow rates, which are associated with increases in inflow precipitation, which is what we'd expect. And then there are the temporal wetting and drying and seasonal variations apparent across the long-term data set. We also see longer moisture retention periods and less pronounced fluctuations with an increase in soil depth. So the sort of soil air interface is more pronounced at the near surface. And yeah, so the start of experimental data period was August 2020, following a period of the commissioning, which I've outlined before. So that's the sort of the long-term data. I'm currently writing up the paper for this data at the moment, so I'm hoping to try and get that out in the next few months. But I also wanted to move on and talk about some of the saturated hydraulic conductivity testing that we did in SUDS. So we know that these systems are important, and current UK CERIA guidance suggests that SUDS substrates should have a KSAT value that provides appropriate retention to attenuate stormwater, but without becoming waterlogged. So it's a really fine balance between holding enough water that we're actually, getting that flood risk benefit, but not holding too much that we're killing off the plants and we're not ready for the next storm event. So based on this, the CERIA SUDS guidance suggests that this saturated hydraulic conductivity can be used as a sort of empirical metric to determine design and assess SUDS performance. And if we're within this 100 to 300 millimeter per hour range of water being able to pass through the bioretention cell, then we're sort of seen as functional. The problem is that in-field evaluations of these systems are rarely conducted, and also we would probably expect that we're seeing variations across the soil depth and also across different vegetation types, and this isn't really fully understood at the moment. So this shows some work that was published in Water. We did an initial laboratory-based characterization of the SUDS media that we were using. And within the lab, this obtained a KSAT value of 101 millimeters per hour. So it's within that 100 to 300 millimeter range, but it's sort of the lower end. But the interesting thing was when we tested this in the field, we saw that in-field surface measurements using this Satro dual heads infiltrometer gave considerably higher readings. And we can see that there's a large error associated with the tufted hairgrass, the Deschampsia cespitosa, for example, but vegetation seems to be having an influence here. So to look at this, we thought, well, let's delve literally deeper into the soil, and we used a Guelph constant head permeameter to determine field KSAT at varying depths across different vegetation types. So this picture here just shows the Guelph permeameter and a series of augured boreholes to look at this. So yeah, series of boreholes were augured to try and capture some of these variations through the engineered soil profile down to the drainage layer across all of the lysimeters, so all vegetation planting styles, to try and determine the influence of soil depth and presence of vegetation. So that diagram just shows the Guelph permeameter in some of these sampling locations as well. And at these locations, we also took some soil samples to extract particle size distribution and field moisture content data. So yeah, I move on to the results from this. So really we see that all lysimeters have higher KSAT readings at the near surface, and this is thought to be due to weathering and wash through processes sort of amending or changing the soil. So maybe the soil that within the lab, it's had that sort of time within the field and it's able to change and be affected by weathering processes. We see a KSAT generally decreasing with the soil depth, and we believe this to be due to consolidation and compaction just under the weight of the system itself, until we obviously get to the drainage layer where we're trying to promote water moving through the system. So we should be getting very low KSAT readings there. Now, the soil depth trends are relatively comparable across all planting styles, but we do see some subtle differences, and we believe that that's reflected because of rooting depth or structure of the vegetation during the augering. So I've actually put the wrong figure up here. I wanted to annotate this figure showing some of those annotations with the roots depths on here, because we do actually see that some of these trends associate with the rooting depths that we observed of the different planting styles. So if we consider Iris sibirica, for example, that has a very kind of rhizome based root structure, but the Deschampsia cespitosa, it really has very, very deep roots that sort of try and scavenge the water and try and suck up as much water from the deep soil profile as much as possible. So I think this is interesting, the plant dynamics, and this is something that the Royal Botanic Garden Edinburgh and myself have been discussing. So they've just got a large programme for the next 5 years, Plants with Purpose, and I think some of this work will feed into their Plants with Purpose programme. And we also have Isla, who's just started doing a PhD within that programme as well, to try and explore how we can put the right plants in suds features. But I think the main sort of take-home message from this work is that from the KSAT testing that we did, maybe the use of a single KSAT value may not be sort of appropriate to try and capture that spatial variability within suds and green infrastructure. So laboratory values, maybe use some caution with using them, and we should perhaps try and validate these within in-field measurements. I think one of the interesting things from this work as well will be revisiting this in 5 years and looking at the sort of degradation and loss of performance. So I think that's something that we've got on the cards. So yeah, in terms of the field moisture content and particle size distribution, we see that the field moisture shows variations with planting styles, which is sort of reflecting the plant transpiration rates and any interception from the canopy vegetation. So obviously larger plant species, you're getting more canopy coverage, so maybe the water isn't able to actually hit the soil itself, and that might affect the particle size distribution and the actual amount of water entering the system. And then also there's the, as we increase the leaf area index and the actual biomass of the plant species, we're getting more water removed from these systems. So yeah, in the bare earth lysimeter, we generally see higher field moisture content, reflecting an increase in water actually entering the soil profile because of that lack of canopy interception, and there's no plant transpirational losses as well. We can generally see that moisture content in vegetated lysimeters generally correlate with plant size and biomass, so an increased transpiration rate. And we also, this was interesting, comparing this back to the initial soil sample that we used. We see that actually the vegetation is kind of amending and changing the soil as the system ages. So again, it would be interesting to revisit this within sort of 2 to 5 years. But really we see very large root mean square error results, so reflecting a bigger change from the initial sample associated with this Deschampsia cespitosa, the tufted hairgrass. So what we're seeing there is actually the vegetation having an impact at breaking down and changing the soil. And this is something that maybe we need to think ahead. Are we designing suds for the future, or do we actually need to incorporate these changes that happen? So yeah, the bare earth lysimeter has the highest gravel component at the surface, also suggesting sort of wash through processes associated with that increased weather exposure due to the lack of shielding from the plants. And the cespitosa, the hairgrass, has an increased sand component, possibly suggesting amendments due to the root soil action and the presence of the vegetation. So I would just say as well, we looked at this in a very sort of controlled, we used a monoculture planting style, but within reality, we are actually using sort of mixed planting schemes which use different plants and a variety of plants. So this is something that Isla is looking at, the plant functional traits, to try and maximize some of those benefits and try and feed into the wider benefits. So I'm going to move on quickly. That was all the stuff that I've done at NGIF, at Newcastle University, and with Sheffield University as well. I'm going to move on to sort of the work that we've been doing with the botanics. So a bit of context, at the botanics, the birch lawn is located on the south side of the grounds, and under heavy rainfall, tree roots and paths, as you can see here, would be flooded, and this resulted in disruption to the gardens. These photos were taken in 2018, I think. But one of the solutions was, well, let's put an experimental rain garden in to try and tackle this flooding and prevent any disruption. So an experimental rain garden was put in. This pie chart just shows the makeup of the soil. So we've got gravel, existing soil, compost and sand. So it's an amended, more infiltratable, more permeable soil. And this just shows one of the drone shots that we've taken of the sort of the components. So essentially the berm is holding water back from entering the pathway. The gravel layer has a kind of more permeable soil, amended soil, to allow water to seep through. And the mulch layer is the same, but that would promote plant growth as well and try and retain water. So this was some work that was done as with an intern student. We looked at sort of testing in field characteristics of the rain garden to sort of assess how well it was performing and whether it was actually doing its job. Anecdotal results have sort of said, well, actually, no flooding has happened here since the rain garden has been put in place, which is obviously a good thing. It's actually seemed to be working. And we did a reclaim workshop a few months back, and it absolutely hammered it down. I think there was about 40 or 50 millimeters of rainfall in that day. It was horrendous weather, kind of apt for a discussion of urban flood risk and green infrastructure, but still the footpaths were completely clear. So yeah, some key results from this work. You'll see that this isn't a complete coverage of the rain garden, and that's partly because of some of the plant species were actually difficult to get in and do some sampling. That top image in the centre, you can see the large gunnera leaves, which are quite spiky and difficult to do some sampling next to them. But generally, we see that infiltration rates, we're seeing much higher infiltration rates within the rain garden. So the grass lawn surrounding is very clayey in its makeup. So we're getting very, very low infiltration rates of 25 to 50 millimeters per hour. And this is the reason why we were getting the flooding in the first place. But the amended substrate has a much higher infiltration rate, so it's actually allowing water through. We see similar trends in terms of the water content and the resistance to penetration, which is essentially a measure of the compaction, kind of correlates quite nicely with some of the infiltration rates. So this suggests a higher ability of water to actually enter and move through the amended substrate soil. So just to wrap up quickly, I think taking all of that stuff, we've been working on sort of outdoor experiments for the past few years. And one of the really difficult things with outdoor experiments is, as much as you want to try and control the variables, it's very, very difficult to do this. So very, very recently, as of October last year, so in the last few months, Bristol University were essentially giving away a large slope experiment facility, which was set up for dryland slope research. This was available as a facility transfer. So I applied to Bristol, and we've actually now got this at Heriot-Watt University, and we're recommissioning it to be an experimental rain garden within the lab. So we're currently in the process of getting all the rainfall simulator set up, putting in the soil, the SUD soil. But this is a really exciting sort of laboratory test bed for me and for botanics as well, who are involved in this new EPSRC impact accelerator projects that we've got. Essentially what we're going to do is play God with those rainfall and inflow characteristics. set this facility up to monitor inflows, outflows, storages. And the idea here is that we're trying to maximize the suds soil, the planting types within a controlled and easily adaptable laboratory environment. So I'm hoping in the next few months, I think by June, July, we should have this set up and running the first sort of set of experimentation. But currently we're in the commissioning phase of the Greenslope facility. So yeah, that's sort of something on the pipeline, but I hope that we can get some great results from that. So yeah, that wraps up my presentation. Thank you so much for listening, and also thank you so much to all of the great people, collaborators and friends that I've worked with to make all of this work possible. And again, thank you to for the opportunity to speak today. Yeah, so that's me. Thank you.
Thank you very much, Daniel. So I'm going to pass it on to my colleague Lawrence to take care of the Q&A session.
So thank you. Yeah, thank you both, Charlotte and Daniel. Really interesting talks. Can you, if any of the audience have got questions, please put them in the Q&A. There's a sort of comment straight question from Lucy Jenkins, actually. It's in the chat, so please try and use the QA. But it's sort of asking whether you've sort of found that children also have anxiety about engaging with other people. So you were talking about whether they felt the space was safe, but is there also anxiety around, have you sort of encountered this about anxiety of children interacting with other kids? Yeah, you're on mute, Charlotte.
Yes, we have. And one of the key aims is having the after school club as inclusive as possible. And there are, a number of children with different needs. And, going out as a group on the public realm can be quite overwhelming and overstimulating. So we have had there's another level of engagement with and considerations that needs to take place in how we keep things inclusive while supporting other sort of specialist needs, I suppose. And what we've done is look to create smaller groups, so looking at a ratio of like one parent or one sort of adult to 3 children, and sort of sharing, sort of being in the same neighborhood with other sort of parents, and actually just sharing the responsibilities. So just really sort of keeping tabs on each other and sort of awareness of what's happening, so we can sort of support each other. So I think there's a lot of anxieties about children going outside, and I think as well from the parents, this sort of increasing age range of when it's okay for a child to sort of be out wandering on their own and exploring the public realm, and the sort of hostilities that are faced in the environment and all the different complexities there, from sort of pollution and roads and all sorts of strangers. So it's complex, but I think what we're trying to do is do something and actually just try to reclaim as much as we can, really.
Have you noticed an interaction between those? So, where children are perhaps more reluctant to engage, or they're not comfortable engaging with other kids. Do you think they found it easier when they're in a kind of green space, or do they find it harder? I'm just sort of interested if there's any sort of interplay between those two.
I think a lot of the school playground stuff gets played out as well, like who wants to go first. Everybody wants to get first, really. So that seems to be the biggest issue of, I want to go first, and then the person who hasn't gone first, and the anxiety there. So it's kind of anxiety is around being in the green, not at all. Everybody's just really keen to just discover and explore and just have the autonomy to just be able to feel and breathe and just walk around in their own terms, rather than getting rushed around with parents. It's such a simple yet profound experience.
Fascinating. Thank you.
Thank you.
If I can put a question to Daniel. I was very intrigued by the lysimeters. I remember studying about lysimeters many years ago. Also interested in that you didn't appear to have replication. So as an ecologist, it's drilled into us that you have to replicate. But that's an aside. I was actually more interested in how you kind of manage the soil and whether, so you put plants in, was the soil sterilized? Or did you inoculate it with earthworms and microorganisms, for example, or was it natural soil so you didn't need to? I'm just sort of interested in that aspect because, we've done a bit of work on looking at how biodiversity underpins ecosystem services. And, earthworms create soil structure and things. So I'm just kind of wondering to what extent it replicated a natural system.
That's a really interesting point actually. Yeah, so we didn't sterilize the soil. Actually, the soil was we got like a sort of off-the-shelf suds soil. So within the lysimeters, that was actually 100% recyclable materials which made up the soil. So things like quarry waste. There's some actual like glass crushings as well that were put in the soil. And the main sort of compost element of the lysimeter soil was made up from sugar beet washing, so an industrial byproduct. And the idea behind this was like it's sort of a green waste, and you're making use of things that would otherwise go to waste. So we bought this from an external company, and we wanted it to try and sort of align with reality as much as possible within suds. So this is a product called Grey to Green, which is the same product that's used all in the suds all across Sheffield. So they've got some quite large suds features across the city. So yeah, same product. So we actually just ordered it from the company, and then once it was delivered from to the site, then we loaded it in. We didn't do any sort of treatment or anything, so we made sure that it was sort of compliant as a suds media, and then put this. We wanted to try and make sure that the material that we were using was as relatable to sort of materials that contractors would have access to as possible. So yeah, I would like to do a bit more sort of more ecological work. It's outside of my expertise, but I think that's a really nice like link up, and there's a lot of work that could be done on the sort of soil microbial properties, and actually the soil ecological makeup as well.
So I guess in a sort of typical sud setting, earthworms are actually quite good at crossing tarmac and concrete over short distances. Whether they can climb up a 1 meter lysimeter is a different question, I guess.
Yeah, I did. There were worms that I observed. So definitely when we were doing the augering, I noticed that there were a lot of earthworms within the soil.
Okay. So they got there somehow.
Yeah, but then also on the flip side, we had the outflow, which would go into the pipes and then those tipping buckets. And when it came to maintenance, I did sometimes have to scoop up a handful of earthworms. So I hope we didn't remove as many, like too many from the system. But it seemed like there was a relatively thriving community within there.
Okay, that's reassuring. Thank you. I think that's probably all we've got time for, actually. So I will pass back to Prashant. But if you've got any questions, either put them in the chat now or email the speakers later.
Yeah, thank you very much, Laurence, for taking care of this session and very interesting questions. And thank you to both our speakers for the fantastic presentations and covering the breadth of the nature-based solutions in different contexts. I think we might have a couple of slides possibly just to finish this session. So Charlotte, I'm just wondering if we can have them. Yeah, so just to finish this, I think we got our next webinar, which is happening on 5th of February. We got two colleagues, one from University of Watt, Dr. Yanis Wenk, and he was talking about the microplastics and and the nature-based solutions in the context of the water, the flood water management. And then another researcher we have is Andrew K. Palmer, and he will be talking about the UK green space settings and their experiences and the perception about it. So we invite you to join the next webinar on 5th of February. If you're not the member of the network, you can still join the network, and there is a link there which is reclaim-network.org. You can follow us on LinkedIn as well as on X, so you can find those updates. And just to reiterate 3 important things which is happening at the moment. The one is the conference on 30th of January. So you can see the link possibly in the chat, or you can go onto the website. So we really invite you to join to this fantastic conference, which we have over 200 people already registered. So it's going to be quite a diverse, the audience coming from the industry and the policymakers and manufacturers, businesses and charities and researchers and so on. The other thing is that we got 2 calls open at the moment. One is for the workshops and the other one is for the secondments. So we really invite you or share those, that news actually among your network. So the workshop ones are basically where you can host a workshop on the topic of the green-blue infrastructure. The secondment is you can either host somebody to your group or you can send somebody to someone else's group, as long as they are within the scope of the green and blue infrastructure of the network. Then I think we'll be very happy to support these sort of secondment opportunities, which has been very successful in the past. And you can see the examples on the Reclaim Network website. Maybe if that's, you can find that information on the website itself, but I believe that you might have those other links in the chat box as well. About these calls there. So with that, I'd like to thank again our speakers for the fantastic presentations, our session chair, Professor Laurence Jones, and our audience actually for coming and spending your time and listening to these things. And you will hear in the next newsletter the links of this recording of this webinars, which are already there on our Reclaim Network, plus a YouTube channel, so you can see them there alongside the past ones. So with that, I'd like to thank everyone again and see you on 5th of February. Before that, possibly in the conference on 30th of January. Thank you. Bye then. Have a nice rest of the day.